Okay, so let's imagine something pretty crazy for a second.
Okay.
You're just going about your day like normal.
Yeah.
And suddenly the news breaks that an asteroid is hurtling towards Earth.
Yeah.
And this thing is huge with a potential impact zone that stretches across continents.
Oh, wow.
Now, how would we even know that this was happening?
Great question.
And what on earth could we possibly do about it?
I mean, that's a pretty unsettling thought, right?
It is.
But luckily for us,
Yeah.
we have some incredible tools to help track these objects, these celestial objects.
Mm-hmm.
And one of the most powerful is the James Webb Space Telescope, or JWST.
Ah, the JWST. Yeah, I've heard so much about this.
Yeah.
Incredible piece of technology.
It really is a game changer.
Yeah.
And, it's been making some incredible discoveries.
I bet.
In fact, it was recently tasked with an emergency mission
Oh, wow.
to study a newly discovered asteroid called 2024 YR4.
2024 YR4. Okay.
Yeah.
That sounds serious.
It is.
What's the story there?
Well, initial calculations show that this asteroid has a 2.3% chance of hitting Earth in 2032.
Wait, 2032? That's not that far off.
No, it's not.
I can see why they called it an emergency observation.
Exactly.
So how did they even find this asteroid in the first place? I mean, space is huge.
Yeah, it's absolutely massive.
Yeah.
So it all starts with these powerful ground-based telescopes.
Okay.
And so scientists will take multiple images of the sky
Okay.
over time, and by comparing these images, they can spot objects that are moving against the backdrop of stars.
Right.
So that's how they found 2024 YR4.
Oh, so it's like connecting the dots, but with stars and asteroids.
That's a great way to put it.
Yeah.
Yeah, and once they've plotted enough of those dots,
Right.
they can calculate the asteroid's trajectory,
Right.
its path through space.
Okay, so it's path through space, and from that trajectory, they can figure out if it might pose a threat to Earth.
Precisely.
Okay.
But it's not always a simple calculate. You have to factor in things like the gravitational pull of planets
Oh.
and other celestial bodies, which can nudge the asteroid off course.
So like a little tug from Jupiter could send an asteroid heading our way.
It's possible.
Oh, wow.
It's possible, and that's why it's so important to have accurate measurements and
Right.
observations.
Yeah.
And that's where the JWST comes in.
Right, you mentioned it was called in for this emergence and observation of
Yeah.
2024 YR4.
Yeah.
What makes the JWST so special for this task?
Well, first of all, its location.
Okay.
The JWST orbits far out in space,
Okay.
about 1,000,000 miles from Earth.
Wow.
That means it has an unobstructed view of the cosmos,
Right.
free from the distortions caused by Earth's atmosphere.
Ah, so it's like having a crystal clear window into space.
Yeah.
No atmospheric blur getting in the way.
Exactly.
And the second thing that makes the JWST so powerful for this kind of work is its infrared vision.
Yeah, it can see heat emitted by objects,
Oh, wow.
even those that are too faint or too far away for other telescopes to detect.
Okay, so the JWST is on the case scrutinizing this potentially dangerous asteroid. What has it told us so far?
Well, initial observations from ground-based telescopes estimated 2024 YR4 to be about 180 feet across.
180 feet. That doesn't sound that big in the grand scheme of things.
You might be surprised.
Okay.
Even an asteroid that size could cause significant damage if it were to hit Earth.
Really? I guess I'm thinking of those planet killer asteroids I see in movies.
Oh,
The
no,
ones
okay.
that are miles wide.
Those do exist.
Yeah.
But even smaller asteroids can pack a punch.
Okay.
Remember the Tunguska event in 1908?
The Tunguska event. Refresh my memory.
Okay, so a relatively small asteroid,
Okay.
estimated to be around 120 feet across,
Okay.
exploded over Siberia
Oh, wow.
with the force of about 15 megatons of TNT.
That's huge.
Yeah, it's a lot.
Yeah.
And it flattened over 80 million trees.
Wow.
And the shockwave was felt hundreds of miles away,
Really?
all without even hitting the ground.
Wow. So even a small asteroid can be a serious threat.
Yeah,
And this 2024 YR4 is even bigger.
exactly, which is why these JWST observations are so crucial.
Yeah.
They'll help us get a much more accurate size estimate,
Right.
which will then help us determine the potential risk.
Okay. That makes sense.
Yeah.
So we've got this one potentially hazardous asteroid on our radar, 2024 YR4.
Right.
And the JWST is helping us learn more about it.
Yeah.
But I'm guessing it's not just focused on this one asteroid, right?
You're absolutely right. The JWST's role in asteroid research is much broader than that.
Okay.
It's been giving us a whole new perspective on the asteroid population in our solar system.
Okay.
For instance, it's been peering into the main asteroid belt between Mars and Jupiter and has uncovered a hidden population of asteroids there.
A hidden population? You mean there are asteroids out there that we didn't even know about before?
Exactly. The JWST's infrared vision allows it to see these asteroids that were previously invisible to us. And some of these newly discovered asteroids have trajectories that bring them relatively close to Earth.
Okay. That's a bit unsettling.
Yeah.
Are we talking about a lot of asteroids here?
The JWST has already identified over 100 new asteroids in the main belt.
Wow.
And that's just the beginning.
Yeah.
And here's a truly mind-blowing fact. The JWST is so powerful, it can detect asteroids as small as 33 feet across.
33 feet? Seriously. That's incredible.
It is.
But also kind of scary. Are there that many tiny asteroids zipping around out there?
It's not necessarily that there are more of them,
Okay.
but that we're now able to see them thanks to the JWST.
Right.
These smaller asteroids are likely the result of collisions between larger asteroids over billions of years.
Okay.
Think of it like a cosmic billiards game with rocks smashing into each other and creating a cascade of smaller debris.
So the JWST is like our cosmic detective.
Yeah.
Uncovering the secrets of these space rocks, both big and small.
That's a great analogy. And remember that unexpected discovery we talked about earlier, where the JWST stumbled upon a tiny asteroid about the size of the Colosseum in Rome while it was being calibrated?
Yeah, that blew my mind. He was just going about its business and boom, new asteroid.
Exactly. That discovery really highlights the incredible sensitivity of this telescope.
Yeah.
It's allowing us to see things we never even dreamed of.
Okay, so the JWST is tracking potential threats, like 2024 YR4, but it's also giving us a much more complete picture of the asteroid population in our solar system.
Yeah.
What does that mean for us here on Earth?
Well, the more we understand about asteroids, their sizes, their compositions, their trajectories,
Right.
the better equipped we are to develop strategies for dealing with potential threats in the future.
So it's not just about watching and waiting, but about using this knowledge to potentially protect ourselves.
Precisely knowing what an asteroid is made of can help us figure out how to potentially deflect it.
Right.
Or mitigate its impact.
So it's not just about watching the skies, but about understanding what's out there and using that knowledge to our advantage.
Exactly.
That's a much more proactive approach.
Exactly. And speaking of watching the skies, the JWST isn't limited to just our solar system.
Oh, really?
Yeah, it can also study objects that originate from outside our solar system,
Okay.
called interstellar objects.
Wait, so there are objects out there that aren't even from our solar system. What are those like?
They're fascinating, and by analyzing the infrared light from these objects, the JWST can help us understand their chemical composition, giving us clues about the formation and evolution of other planetary systems.
Wow. So this telescope is giving us a window into the vastness of space.
It is.
Both near and far.
It really is. It's helping us unravel the mysteries of our own solar system and getting us glimpses into the incredible diversity of worlds that might exist beyond our own.
It's incredible to think about all the discoveries we're making and all the secrets that are yet to be revealed. It really makes you wonder what else is out there just waiting to be found.
That's the beauty of science, isn't it?
Yeah.
There's always something new to discover, always another mystery to solve.
Yeah.
And with the JWST leading the way, I have no doubt that we'll continue to make groundbreaking discoveries for years to come. And it really is a remarkable time for space exploration, and you're right here along for the ride with us.
I am definitely ready for the ride. You know, we've been focusing on asteroids, but what about comets? I know they can be pretty spectacular.
They are.
And potentially dangerous too, right?
Absolutely. Comets are essentially these giant snowballs
Yeah.
of ice, dust, and rock, and as they get closer to the sun,
Okay.
they heat up and release gas and dust, creating those beautiful tails we see streaking across the sky.
Right, so they're not just beautiful, they're also made of the same stuff that was around when our solar system formed, right?
You got it. And the JWST can help us study the composition of comets,
Okay.
giving us even more clues about the early days of our solar system.
Yeah.
And, of course, it can track their trajectories, just like with asteroids, to see if they pose any threat to Earth.
Okay, so we're talking about asteroids and comets. These celestial objects zipping around our solar system.
Right.
Let's circle back for a sec to that what-if scenario we started with.
Okay.
An asteroid heading straight for Earth.
Yeah.
What can we actually do to stop it?
That is the million-dollar question.
It is.
And the answer, like so much in science, is it depends.
Okay.
It depends on the size of the asteroid, how much warning time we have, and a whole host of other factors.
I see. So there's no one-size-fits-all solution.
Not exactly. But scientists and engineers around the world are working on several potential strategies.
Okay.
The key, of course, is early detection.
Yeah.
The sooner we know about a potential threat,
Right.
the more time we have to react.
Makes sense. So time really is our most valuable asset in this situation.
Absolutely.
Yeah.
And that's why the JWST's role in early detection
Right.
is so crucial. But let's say we have plenty of warning time and we know an asteroid is on a collision course with Earth.
Okay.
What can we do?
What can we do?
Well, one option is to try and nudge the asteroid off course.
Nudge it. How do you nudge a giant space rock?
It might sound like science fiction,
Yeah.
but there are some intriguing possibilities being explored.
Okay.
One is what we call a kinetic impactor.
A kinetic what?
A kinetic impactor. And it's basically a spacecraft that you slam into the asteroid
Oh, wow.
at high speed.
Okay.
And the impact would transfer momentum to the asteroid ever so slightly, altering its trajectory.
So it's like a cosmic game of pool, except with the fate of the Earth at stake.
You could say that another option being considered is a gravity tractor.
A gravity tractor. What's that?
It's a spacecraft that would fly alongside the asteroid for an extended period,
Okay.
using its own weak gravitational pull to very gradually tug the asteroid off course.
Wow. So it's like a cosmic tow truck, slowly but surely pulling the asteroid away from Earth.
That's a great analogy.
I like it.
Now, of course, these methods are still in the theoretical stage.
Right.
But they demonstrate the kind of creative thinking that's going into planetary defense.
Yeah, it's mind-blowing to think that we might actually be able to deflect an asteroid if we had to.
Yeah.
It really shows you how far science and technology have come.
It does. And the JWST is a crucial part of that progress.
Right.
It's not just helping us understand these objects, but it's giving us the information we need to potentially protect ourselves from them.
Okay, but let's be realistic for a second.
Okay.
What are the actual chances of an asteroid hitting Earth in our lifetime? I don't want to start losing sleep over this.
Well, the good news is that large asteroid impacts the kind that could cause global devastation
Right.
are incredibly rare.
Okay.
They happen on timescales of millions of years.
Okay, that's slightly reassuring.
Yeah.
But what about smaller impacts like the Tunguska event? Those seem to happen more frequently.
You're right. Smaller impacts are more common.
Okay.
And while they might not cause global devastation, they can still cause significant damage on a regional scale.
Yeah.
So we can't afford to be complacent.
So we need to stay vigilant and keep learning as much as we can about these space rocks.
Absolutely. And that's one of the reasons why the work being done with the JWST is so exciting.
Yeah.
It's giving us an unprecedented view of the solar system and helping us unravel the mysteries of these celestial objects.
It's amazing to think about how much we've already learned from the JWST, and it's only been operating for a couple of years.
Imagine what we'll discover in the years to come.
Yeah.
Who knows, maybe someday we'll even be able to mine asteroids for resources or use them as stepping stones for deep space exploration.
Whoa, mining asteroids. Now that's an idea I haven't heard before.
It's a really interesting concept.
Yeah.
Can you tell me more about that?
Sure. Some asteroids are rich in valuable resources like water metals
Okay.
and even platinum.
Wow.
And some scientists believe that we could one day extract these resources, using them to support space missions or even bring them back to Earth. So we could have cosmic mining operations. That sounds like something out of science fiction.
It does, but it's a real possibility. And the JWST is helping to make that dream a reality by giving us a much clearer picture of what these asteroids are made of.
So it's not just about avoiding impacts, but about potentially using these space rocks for our benefit.
Asteroids could become stepping stones for humanity's expansion into space.
It's incredible to think about all the possibilities. It really makes you realize how much potential there is out there just waiting to be unlocked.
And the JWST is helping us unlock that potential. It's not just a telescope. It's a key that's opening doors to new discoveries and new possibilities.
That's a great way to put it. It's like we're on the cusp of a new era of space exploration, and the JWST is leading the way.
And you're here with us learning about all the amazing things it's revealing about our universe.
It's an honor to be along for the ride. So what's next for the JWST in terms of asteroid research? What other mysteries is it going to help us solve?
Well, one of the most exciting areas of research is the study of asteroid composition.
Composition. What exactly do you mean by that?
I mean, what are these asteroids made of?
Okay.
What kind of minerals and elements do they contain? The JWST's infrared instruments are perfectly suited for this type of analysis.
Right.
By studying the light emitted by asteroids, we can learn about their chemical makeup.
And why is that so important? I mean, besides just knowing what they're made of.
It's important for several reasons.
Okay.
First, it helps us understand the formation and evolution of our solar system.
Oh, okay.
Asteroids are like time capsules, preserving material from the early days of our solar system.
Yeah.
By studying their composition, we can piece together the story of how our planets and everything else came to be.
So they're like cosmic fossils.
Exactly. And secondly, knowing the composition of asteroids could be crucial for future space exploration. If we know what they're made of, we can determine which ones might be most useful for resource extraction or even for building habitats on.
Ah, so we're back to the idea of mining asteroids and maybe even living on them someday.
You got it. The possibilities are truly endless.
Yeah.
And the JWST is helping us lay the groundwork for that future by giving us a detailed look at what these asteroids are made of.
It's incredible to think about how something as seemingly simple as studying the composition of an asteroid could have such far-reaching implications.
It's true, and that's what makes science so fascinating.
Yeah.
Sometimes the most unexpected discoveries can lead to the most groundbreaking advancements.
So it's not just about the big, splashy discoveries, but about the smaller, more detailed observations that help us build a complete picture of the universe.
Exactly, and the JWST is a master of both.
Yeah.
It can capture stunning images of distant galaxies and nebulae, but it can also analyze the faintest whispers of light from a tiny asteroid, giving us insights into the building blocks of our solar system.
You know, one of the things that always amazes me about the JWST is its ability to see things that were previously hidden from us.
Like those tiny asteroids and comets we talked about.
Right, exactly. And even more than that.
Yeah.
The JWST is so sensitive.
Yes.
It can detect the faintest traces of heat and light, allowing it to peer into the darkest corners of the universe.
It's true.
So it's like having a superpower,
Yeah.
being able to see things that were previously invisible.
Exactly. And that's what makes it such a powerful tool for discovery. It's giving us a whole new perspective on the universe, revealing things we never even imagined.
And that brings us back to our original question.
Yeah.
As the JWST continues to scan the cosmos,
Right.
what other unexpected discoveries about asteroids and other celestial objects might await? And what will these discoveries teach us about our place in the universe?
It's a question that sparks the imagination. Every time the JWST sends back new data, it's like opening a present, never knowing what wonder might be revealed inside.
It's like the universe is constantly surprising us, reminding us how much we still have to learn.
And that's what makes it so exciting. The pursuit of knowledge, the thrill of discovery, that's what drives us forward.
Well said. And with the JWST leading the way, I can't wait to see what other amazing things we'll uncover about the universe in the years to come.
Me neither. It's a truly remarkable time to be alive, witnessing the dawn of a new era in space exploration.
It is. You know, we started this conversation talking about asteroids as potential threats, and now we're talking about them as resources and stepping stones to further exploration. It's amazing how our perspective can shift when we learn more about something.
It's true. Knowledge has a way of doing that. And that's why missions like the JWST are so important.
Right.
They expand our understanding, challenge our assumptions, and open up new possibilities.
And speaking of possibilities, remember we talked about those smaller asteroids, the ones that are constantly colliding and fragmenting.
Yes.
What happens to all those tiny pieces of debris? Do they just float around in space forever?
Well, some of them do.
Okay.
But many of them end up falling to Earth as meteoroids.
Oh, like shooting stars.
Exactly. Most of these meteoroids are tiny, burning up harmlessly in the atmosphere as they enter.
Okay.
But occasionally a larger one makes it through.
Oh, wow.
Creating a spectacular fireball, and sometimes even leaving behind fragments, meteorites that we can study here on Earth.
So those meteorites we see in museums, those are actual pieces of asteroids that fell from space.
That's right. They're like little pieces of the cosmos delivered right to our doorstep. And by studying their composition, we can learn even more about the history and evolution of our solar system.
It's incredible to think that we can hold a piece of an asteroid in our hand, something that's been traveling through space for billions of years.
It really is a remarkable connection to the vastness of the universe.
Yeah.
And it reminds us that we're not just observers, we're participants in this grand cosmic dance.
Well said. And as we continue to explore and learn, who knows what other amazing discoveries await. Maybe someday we'll be sending astronauts to asteroids, mining them for resources, or even building habitats on their surfaces.
The future of space exploration is full of possibilities. And with powerful tools like the JWST at our disposal, I have no doubt that we'll continue to push the boundaries of human knowledge and understanding.
It's an exciting time to be alive.
Yeah.
And for anyone who wants to learn more about this incredible field of research, I encourage you to keep an eye on NASA's website and other science news sources.
Right.
There's always something new and fascinating to discuss.
Absolutely. And remember, the next time you see a shooting star streaking across the night sky, take a moment to appreciate its cosmic journey and the incredible story it tells about our place in the universe.
That's a beautiful thought.
Okay.
Thanks for joining me on this journey into the world of asteroids and the JWST.
Of course.
It's been an illuminating experience.
It's been my pleasure. It's always a joy to share the wonders of space exploration with curious minds.
Until next time, keep looking up.
And keep exploring.
It really is amazing to think about, how much we're learning about asteroids in the universe thanks to the JWST.
It's true. It truly is a game changer, and the best part is that you're learning about it alongside us in real time.
It feels like every day there's a new discovery or a new image that just blows my mind.
It is an exciting time.
But I have a question about all these asteroids we've been talking about.
Okay.
If they're not on a collision course with Earth,
Yeah.
what happens to them?
Yeah.
Do they just drift through space forever?
Well, space is vast, and many asteroids do just that, drift along for billions of years.
Wow.
But some of them eventually get caught in the gravitational pull of planets or other objects.
Oh, okay.
And sometimes they collide with each other,
Right.
creating those smaller fragments we talked about earlier.
Right, the cosmic billiards game.
Exactly.
But what about those smaller pieces? Do they all just become part of the asteroid belt, or do they end up somewhere else?
Some of them do join the asteroid belt, but many of them end up on different paths, sometimes even crossing Earth's orbit.
Okay, and that's where things get a little nerve-wracking, right? Because if one of those fragments is headed our way...
That's when we rely on those early detection systems and those planetary defense strategies we were discussing earlier.
Right.
But here's something interesting to think about.
Okay.
Most of the smaller fragments that enter Earth's atmosphere don't pose a threat at all.
Really? Why not? I thought any space rock hurtling towards Earth would be a cause for concern.
Well, it depends on their size and composition.
Okay.
Most of these fragments are incredibly small,
Okay.
like grains of sand or pebbles.
Oh, wow.
And as they enter the atmosphere at high speed, they burn up due to friction with the air.
Oh, so they're like shooting stars.
Exactly. Those streaks of light you see across the night sky, those are often tiny meteoroids burning up as they enter the atmosphere. It's a beautiful and harmless reminder of the constant interplay between Earth and the cosmos.
That's a much nicer way to think about it than an impending asteroid apocalypse. But what about the fragments that don't burn up completely? What happens to those?
Those are the ones that can make it to the ground, becoming meteorites.
Like the ones we see in museums.
Exactly. Those meteorites are pieces of asteroids that have survived the fiery journey through the atmosphere and landed on Earth.
Wow.
They're like little pieces of the cosmos delivered right to our doorstep.
It's incredible to think that we can hold a piece of an asteroid in our hand, something that's been traveling through space for billions of years.
It really is a remarkable connection to the vastness of the universe.
Yeah.
And by studying these meteorites, scientists can learn so much about the early solar system.
Oh, wow.
The formation of planets, and even the origins of life itself.
Wow, so these space rocks aren't just potential threats.
No.
They're also incredible sources of information about our place in the universe.
You got it. They're like cosmic messengers carrying secrets from the distant past.
Wow.
And the JWST, with its incredible sensitivity and powerful instruments, is helping us decipher those messages, revealing the hidden stories written in the stars.
It's truly an exciting time to be interested in space exploration. It feels like we're on the verge of so many incredible discoveries.
We are. And thanks to missions like the JWST, you're able to follow along on this journey of discovery, learning about the latest findings and the mysteries that still lie ahead.
Well, I, for one, am hooked. Thanks for taking me on this deep dive into the world of asteroids and the JWST.
Absolutely.
It's been an incredible journey.
It's been my pleasure. Remember, the universe is full of wonders, and there's always something new to learn.
Yeah.
Keep exploring. Keep asking questions.
I will.
And keep looking up at the stars.
I will. And to everyone listening, Thank you for joining us on this cosmic adventure.
Yes, thank you.
We'll see you next time for another deep dive into the fascinating world of science and discovery.